Hello, and welcome back to another video that's going to help inspire you to succeed on the TEAS exam, particularly for the chemistry part. My name is Professor TK the Chemist, and I'm going to give you guys some tips and tricks on how to make this section of Le Chatelier's principle understandable with ease. Are you guys ready? Let's get into it. First off, I want to explain to you all why Le Chatelier's principle is important to understand for nurses. Well, Le Chatelier's principle helps predict how biological and chemical systems respond to changes, which is essential in patient care. Now, in case you didn't know, it plays a crucial role in healthcare, especially in nursing. Why? Well, it helps us to understand how the body maintains balance and homeostasis in response to changes. So, just like how a chemical system adjusts to restore equilibrium, the human body responds to disruptions such as changes in the blood pH, oxygen levels, or medications by shifting processes to restore normal conditions. So, this concept is vital for nurses like you guys when monitoring patients' reactions to treatments or changes in their environment. Now, what I'm going to do is show you all these examples using chemical reactions and equations to help you get a better understanding of Le Chatelier's principle. Let's go. Le Chatelier's principle. Can you tell I like to say that name, Le Chateliers? I took a little bit of French when I was in middle and high school. Can I still speak it? Not quite, but here we go. Le Chatelier's principle states that if a dynamic equilibrium is disturbed by changing the conditions such as concentration, temperature, or pressure, the system will adjust itself to counteract the change and restore a new equilibrium. The purpose is to help predict the direction of chemical reactions when conditions change, which is crucial for understanding many biological and chemical processes. One of the dynamic equilibrium concepts that you need to be familiar with is that it is a state where the rate of the forward reaction equals the rate of the reverse reaction, and the concentration of reactants and products remain constant. So let me give you 4 things that are also going to affect equilibrium. Number 1, concentration. Adding or removing reactants and products shifts equilibrium to balance changes. You know, we've talked about concentrations before in prior conversations when we discussed molarity. So when we're talking about the concentration factor of a chemical reaction, particularly the reactants or products, this is one of those things that can actually alter Le Chatelier's principle. Number 2, temperature. Increasing temperature favors the endothermic reaction. Decreasing favors the exothermic reaction. So you want to make sure that you are familiar with what endothermic means versus exothermic. Endothermic means you are absorbing heat. Exothermic means you're going to release it. And the third thing, pressure. Well, if you're increasing pressure, it favors the side with fewer gas molecules. By decreasing the products, you're going to favor the side with more gas molecules. So make sure that when you think about pressure, if you're increasing or decreasing, it's going to favor the side based on those gas molecules. Catalyst, that's something that's going to actually speed up a reaction, okay? So a catalyst increases the rates of both the forward and reverse reactions equally. This means that the reaction will reach equilibrium faster, but the actual position of the equilibrium does not change. So let's take a look at some practical examples in which you're going to have to be familiar with the Le Chatelier's principle on the TEAS exam. So number 1, change in concentration. So take a look at this chemical reaction. You have nitrogen reacting with hydrogen to form ammonia. All right, here's the deal. If you change the concentration, in this particular case, if you're adding more hydrogen, which is right here on the left-hand side, on the reactant side, it's going to shift the equilibrium to the right, which is going to produce more ammonium, more NH3. Number 2, changing the temperature. Remember, if you have an exothermic reaction, you are increasing temperatures, which is going to shift equilibrium to the left, favoring the reactants. Number 3, changing pressure. Again, in the same example, nitrogen reacting with hydrogen to form ammonia. If you're increasing pressure, it's going to shift equilibrium to the right, favoring the side with fewer gas molecules, H3 in this particular case. And then number 4, adding a catalyst. Remember, as I said before, if a catalyst is added to this reaction, it will speed up the reaction on both the formation of ammonia and its decomposition back to nitrogen and hydrogen. However, the concentrations of nitrogen, hydrogen, and ammonia are at equilibrium and will remain the same as they would be without the catalyst. Okay, so I want you to remember as you look at this chart here, how all these things will make sense when you think about things that will alter the outcome of your concentration factors, the temperatures, the pressures, and catalysts. Notice how what you have on the left side, which are your reactants, how they'll change based on the product side, okay, as a result of these 4 different types of examples. So let's go ahead and discuss why this is important in understanding Le Chatelier's principle in healthcare. Well, number 1, when you're understanding drug reactions in pharmacology, it's going to help you understand how drugs interact with the body and how the body maintains equilibrium because it is essential for safe and effective medication administration. So if you think about it, there are certain drugs you cannot take with certain foods. And if you take them together, one will cancel out the other. There are 2 classic examples I can think of. If you're on blood thinners, there are certain vitamins you should not take. There are certain foods you should not eat, like kale, because it will actually have a negative effect on the medication because of the amount of vitamin K that's in kale. Put a lot of your green leafy vegetables in that case. The second example, birth control pills versus an antibiotic. Oftentimes, when patients are taking both at the same time, they will notice how ineffective their birth control medication will be because the antibiotic has a stronger hold in terms of canceling out that effect. And as I jokingly tell my students, this is what happens 9 months later when you have a wah, 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 baby ringing at the end of it all. So again, this is one reason why Le Chatelier's principle is important, because you are understanding how the drug interactions in pharmacology affect the body's maintenance for equilibrium. Number 2, blood gases and respiration function. Le Chatelier's principle helps explain how the body regulates pH through the carbonic acid bicarbonate buffer system in the blood. Again, it's going to help adjust carbon dioxide levels because those impact the rates, your breathing rates, and your blood pH. Think about it. Have you heard of alkalosis and alkatosis? Okay, that deals with carbon dioxide levels in the blood. Okay. Number 3, homeostasis and metabolic reactions. Well, with equilibrium principles, they apply to the metabolic pathways in homeostasis, helping healthcare professionals understand how the body responds to changes in diet, exercise, or disease. So let's take a look at this chart, because this chart is going to be very important for you to understand the effects of condition changes on equilibrium. So as you look at the chart, you can just look at the conditions, the effect on equilibrium, and then an explanation. So here's the first thing that you all need to be familiar with. Concentration changes. If a substance's concentration increases, equilibrium shifts to consume the added substance. If a substance concentration decreases, equilibrium shifts to produce more of the removed substances. So as you can see here from your chart, let me just kind of highlight that for you, okay? So you can see what I'm talking about. So right here, the concentrations, these 2 parts right here, increasing in concentration, what it does versus decreasing in concentration. If I were you, I would make sure to put them on note cards so that you can remember that concept. Write them down. Write down what happens when you increase the concentration versus decreasing the concentration so that it becomes a part of your memory bank in terms of remembering this for the TEAS exam. Now, number 2, temperature changes. As we talked about before, if the temperature increases, equilibrium is going to shift towards the reaction that absorbs heat, meaning an endothermic reaction. On the other hand, if you have a temperature change that actually decreases, equilibrium is going to shift towards the reaction that releases heat, hence the word exothermic, okay? So again, look at the chart. Use this chart to your advantage in terms of understanding what happens when you increase the temperature versus decreasing the temperature. Here's some more conditions you need to be familiar with once again. Pressure and volume changes, okay? So here's what happens. Increasing pressure by decreasing the volume shifts equilibrium towards the side with fewer gas molecules. We stated that earlier. So as you can see here, look at the chart. Again, put them on index cards as I've stated before, so you will be familiar with those different conditions. Decreasing pressure or by increasing volume shifts equilibrium towards the side with more gas molecules, okay? So again, just look at the chart, put those conditions on your index cards so you will know them like that. Another thing, catalysts and inert gases. Adding a catalyst does what? What did I say earlier? It does what? It speeds up the reaction, but does not change the equilibrium position. Adding an inert gas at constant volume does not affect the equilibrium position either. So again, you want to be familiar with the conditions that don't change a thing, okay? It's just going to stay the way it is. Whether you add the catalyst or not, it's going to stay the way that it is, okay? Just a little tip to help you remember. Again, put them on those index cards. Here's your first example. Concentration change. You have nitrogen plus hydrogen producing ammonia. The reactant side is nitrogen and hydrogen. The product side is ammonia. So here's a scenario. Let's say that you added more hydrogen to the system. What do you think is going to happen? Well, remember what we discussed before. The equilibrium will shift to the right to produce more ammonia gas. Okay, so remember, the side that you add more of is going to shift to the opposite side. Okay, just FYI, so you can remember that. Because we're going to actually do some TEAS questions to see if you can infer these same concepts based on the 4 variables we talked about in terms of Le Chatelier's principle. Example number 2, suppose we change the temperature. So here's your reaction example. Sulfur dioxide reacts with oxygen to form sulfur trioxide. You have an exothermic reaction. So here's the scenario. The temperature is increased. What do you predict is going to happen? According to that chart, the equilibrium will shift to the left, favoring the reactants, as the temperature tries to absorb the added heat. Example number 3, pressure change. Here's your reaction example. CO plus hydrogen produces CH3OH. Here's your scenario. The pressure is increased by decreasing the volume. What do you think is going to happen? Well, remember, the equilibrium will shift to the right, favoring the side with fewer gas molecules. Okay? Example number 4, adding a catalyst. Here's your reaction example. You have hydrogen plus iodine producing hydroiodic acid. Here's your scenario. What is the effect of adding a catalyst? We talked about this before. Remember, there will not be a shift. It will speed up the reaction, but it will not have any impact on the equilibrium position. Okay? TEAS question time. Here's your first question. If more reactant is added to a system at equilibrium, which of the following will show how the equilibrium shifts according to Le Chatelier's principle? Will it A, shift towards the products, B, shift towards the reactants, C, no shift, D, depends on the reaction? The correct answer is A. It will shift towards the products. Remember, according to the Chatelier's principle, when a system at equilibrium is disturbed, the system will adjust itself to counteract the disturbance and restore a new equilibrium. If more reactant is added to the system, it creates an imbalance. The system will try to counteract an increase in reactant concentrations by shifting the equilibrium towards the products to use up the added reactants and produce more products. So this is how the system reduces the stress caused by the increased reactants. Now let's take a look at why the other answer choices are incorrect. So letter B says it'll shift towards the reactants. Well, we know that is incorrect because adding more reactants does not cause the system to shift towards the reactants. Instead, the system shifts in the opposite direction towards the products to reduce the added reactants. Letter C, no shift. Well, we know that is also incorrect because adding more reactants disturbs the equilibrium. According to Le Chatelier's principle, the system must shift to counteract this change, meaning there will be a shift, not no shift. And then finally, letter D, it depends on the reaction. Again, this is incorrect because while the specifics of the reaction, such as reaction types, conditions, etc., influences the behavior of the system, Le Chatelier's principle always predicts a shift towards the products with more reactant is added. So whenever you add more reactant, regardless of the reaction type, this is dependent on the reaction in this context. Okay? Question number 2. For the exothermic reaction of nitrogen plus hydrogen producing NH3, ammonia, plus heat, what happens to the equilibrium position if the temperature is increased? Does it A, shift to the right, B, shifts to the left, C, no shift, or D, cannot be determined? The correct answer is B, shifts to the left, and here's why. For an exothermic reaction, heat is considered a product because the reaction releases heat. The reaction can be represented as what you see here, N2 plus H2 producing NH3 and heat. According to Le Chatelier's principle, if the temperature is increased, the system will attempt to counteract this change by shifting in the direction that absorbs the added heat. Since this is an exothermic reaction, increasing the temperature adds more heat to the products. The system responds by shifting the equilibrium towards the reactants, which is the left side, to reduce the amount of heat by favoring the reverse reaction, which consumes heat. Now let's take a look at why the other answer choices are incorrect. Letter A says shift to the right. Well, this is incorrect because a shift to the right would occur if the system needed to produce more heat. However, increasing the temperature in an exothermic reaction causes the system to shift towards the reactants on the left to absorb this excess heat. Letter C, no shift. Well, you know this is incorrect because increasing the temperature disturbs the equilibrium. Le Chatelier's principle predicts a shift in response to this disturbance. And then finally, D cannot be determined. Well, we know this is incorrect because the effect of temperature changes on equilibrium in exothermic and endothermic reactions will be understood, okay? And so for an exothermic reaction, increasing the temperature always causes a shift towards the reactants, which is on the left side in this particular example. Question number 3. In the reaction, carbon monoxide plus water producing carbon dioxide, what happens if the pressure is decreased? A, shifts to the right. B, shifts to the left. C, no shift. Or D, depends on the volume. The correct answer is C, no shift. Here's why. When considering the effect of pressure changes on a system at equilibrium, Le Chatelier's principle states that the system will shift to minimize the change in pressure if there is a difference in the number of moles of gas on each side of the reaction. So if you look at this reaction here, you'll notice that there is 1 mole of gas on the reactant side for carbon monoxide and water, and 1 mole of carbon dioxide on the product side. Since the number of moles of the gas is the same on both sides, a change in pressure, whether increased or decreased, does not affect the equilibrium position because the system is not influenced by pressure changes when the number of gas molecules remains constant. So let's take a look to see why letters A, B, and D are incorrect. Letter A says it'll shift to the right. Well, we know this is incorrect because a pressure decrease only affects the equilibrium if the number of moles of gas differs between reactants and products. In this case, the moles are equal. Letter B shifts to the left. Well, again, this is incorrect for the same reason. Since there are no differences in the number of gas molecules, pressure changes do not shift the equilibrium. And then finally, letter D depends on the volume. This is incorrect because volume changes would affect the system if there was a difference in the number of moles of gas. However, in this reaction, pressure changes do not cause a shift, and the volume dependency is what? Irrelevant, okay? Question number 4. For the endothermic reaction, calcium carbonate produces calcium oxide plus carbon dioxide. What will happen if the temperature is decreased? Shifts to the right for letter A, shifts to the left for letter B, C, no shift, or D, cannot be determined. The correct answer is B. It will shift to the left. And here's why that answer is the correct one. In an endothermic reaction, heat is absorbed as a reactant. So for this reaction here, heat is required for the decomposition of calcium carbonate, which means that the forward reaction to the right is endothermic. According to the Chatelier's principle, if the temperature is decreased, the system will try to counteract this change by shifting the equilibrium to produce more heat. Since heat is absorbed in the forward reaction, the system will shift to the left to favor the reverse reaction, which releases heat, so it can compensate for the temperature drop. Now let's talk about why the other answer choices are incorrect. A, it shifts to the right. Well, this is incorrect because a shift to the right would absorb heat, which is not what the system wants to do when the temperature is decreased. So this system instead will shift left to release that heat. And then letter C says no shift. Well, this is incorrect because a decrease in temperature will disturb the equilibrium, causing a shift. And finally, letter D, the reason why it cannot be determined is incorrect is because the temperature changes on endothermic and exothermic reactions are well understood. So for an endothermic reaction, decrease in temperature shifts the equilibrium towards the reactants, which are on the left in this particular example here. Here is your final TEAS question. Question 5. For the equilibrium of PCl5, which decomposes into PCl3 plus CO2, what happens if CO2 is removed from the system? Does it A, shift to the left, B, shifts to the right, C, no shift, or D, equilibrium is destroyed? The correct answer is B, shifts to the right. So here's why that is the correct answer. According to Le Chatelier's principle, when a system at equilibrium is disturbed, it will shift in a direction that counteracts the disturbance. So in this reaction here, where we had phosphorus pentachloride decomposing into phosphorus trichloride and chlorine gas, if it is removed from the system, that means it's going to affect the concentration by decreasing it. So to restore the equilibrium, the system will shift to the right, which is towards the products, to produce more chlorine and compensate for its removal. So let's talk about why the other answer choices are incorrect. Letter A says it shifts to the left. Well, we know that is incorrect because removing chlorine causes the system to shift right to the place the lost chlorine, not left. Okay, so it's going to shift to replace the lost amount of chlorine and not to the left side. Now, when you look at letter C, saying that there's no shift, that is incorrect because removing chlorine actually disturbs the equilibrium. So the system will shift in response. And then finally, letter D, where it says equilibrium is destroyed. This is incorrect because equilibrium is not destroyed by the removal of chlorine. In fact, the system will shift to reestablish equilibrium by producing more chlorine. So there's one final note that I wanted to provide you guys with, and that is, how do you apply Le Chatelier's principle in the form of a graph? Well, take a look at this graph here. This graph is going to illustrate the effect of a catalyst on activation energy and equilibrium positions in chemical reactions. So on the x-axis, you have reaction coordinates, and on the y-axis, you have your energy. There are different coded colors also to kind of give you an idea of what happens when you have activation energy, when you have a catalyst versus not. Okay, so without the catalyst, that's the red little dashes that you see, the activation energy is higher, which indicates the peak of the curve. This represents the energy barrier that must be overcome for the reaction to proceed. Now, if you have another example where there's a catalyst added, this is where your blue line is going to be. And this catalyst shows that the catalyst was lowered the activation energy. And then as you can see here, this makes it easier for the reaction to occur by reducing the energy barrier. And then finally, when we talk about equilibrium positions, you'll notice that there are some green lines and some orange dotted lines. So again, the energy levels of the reactants and products remain unchanged, indicating that the catalyst does not affect the equilibrium position. The system still reaches the same balance between reactants and products, but it does so more quickly due to the lower activation energy. So just make sure that you're mindful of what you see here in your observations of this data. Okay? And finally, you're going to realize that this visualization is going to help you illustrate that while a catalyst speeds up the reaction by lowering the activation energy, it does not shift the equilibrium position or after the final concentration of reactants and products. So I just want you to be mindful that you will see charts and graphs on your TEAS exam, and it's your interpretation of what you see as to whether or not you understand that particular concept. So here's a mnemonic for factors affecting equilibrium. CAT-P, okay? Concentration, add, remove reactants or products. Temperature, pressure changes. This helps you remember the three main factors that change in concentration, like add or remove reactants and products, temperature changes, and pressure changes. So again, something that you can add to your what? Note cards. And if you notice the images that I put on this screen here, on this document, think of equilibrium as a balance, equilibrium, balance. If you add weight to one side, meaning change concentration or pressure, the balance tips. The system adjusts to restore balance. And finally, remember, heat can be a reactant or product depending on whether the reaction is what? Endothermic or exothermic. Visualize how adding or removing heat affects the reaction direction. So here are my final thoughts on Le Chatelier's principle. Remember, it'll help you predict how biological and chemical systems respond to changes, which is essential in patient care. And it will also help you to understand processes like drug interactions, respiratory functions, and metabolic balance. And finally, mastering this principle enhances critical thinking skills needed for effective problem solving in clinical scenarios. Good luck on your TEAS exam, and if you have further questions, please don't hesitate to pause the video, go back and write your questions and comments down, and perhaps your question will be answered right along with the video. Always keep those note cards on standby, along with your markers, pens, highlighters, so that you can go back and reevaluate the concepts that caused you some issues with understanding the information. make sure you go back and reevaluate the chart, the graphs that were presented in this particular lesson. Okay? So good luck on your TEAS exam, and I'll see you on the next video.